problem statement as the truck carries 1200 pound safe which has a center of mass at point G. What is the largest acceleration of the truck so that the safe will not slip or tip on the truck bed? The coefficient of static friction is given as 0.5. Okay. Then we will use the equations of motion to solve the problem. The first thing is the safe free body diagram. This is point G. We have the weight. We have a normal force. We have the acceleration of the body in x direction. So then we have the frictional force. The question is that is frictional force to the left or is it to the right? This is the question. If you think of this way, okay, the car moves to the left, not moves, let's say accelerates. Okay, and then safe tries to move to the right. By Newton's first law, inertia. It has inertia that tries to keep in place. And then, as a result, F friction force will act against the motion. Therefore, to left. Okay. The safe tries to move that way. Friction force tries to move this way to oppose the change in action. That will be the direction of the friction force. Since you did the free body diagram with respect to the G, that's very important, then the rest is coming as a piece of cake. So let's start with the first one. F of x is ma into x of G. F of y will be m into a y with respect to G. And then finally the moments about G should be equal to 0. Okay, then let's start with the first case. The forces in x direction. This is our y, this is our x. We have a negative friction force. Okay, that will be equal to negative m a g in x direction. And then what are the unknowns? The f and then ag. So we have two unknowns. We have one equation. Comes the second equation. So we have the weight downwards, normal force upwards, acceleration 0. The body doesn't move in y direction. I mean, it's not logical, yes. Then the n will be w. So we have one equation, then we have one unknown, which is the n. Okay. Since w is known, we can find the n. That doesn't change anything. Yes, we have one equation, one unknown. Total we have two equations and three unknowns. We need one more equation that will be that f of f, the frictional force, will be the friction coefficient into the n. Okay, and then we will have this one will be 1200, and then f of s is 0.5. From here it follows that f of f is 600 lb. Then we go back here. Then ag of x will be that f of f, which is 600, times the mass of the body, which is 1200 divided by 32.2. That's the mass of the body. This one cancels out. Then ag in x direction will be 16.1 feet per second squared. Okay, but the problem is we have found the acceleration. There is no problem. But is it safe? So is this agx safe? Safe means that the safe, we have two synonyms at once. Safe will not rotate, or rotate, yes. Tip, we can say. Tip on bed. Is it safe? And to find this one, we are going to use the moment equation. Okay. The moment equation says that this is the safe. This is the weight, and then we have the normal N. Friction F. Okay, so if we start one by one, let me just stop it, put it here. Then we have the frictional force with an arm of this much. That is given us in the question as 2.5 feet. That's the arm for frictional force. And then F of F times 2.5. That's clockwise and negative. Clockwise, we will take it as a negative. Now comes the N. And this one should be equal to 0. This clockwise moment must be counterbalanced by some counterclockwise moment. Okay, that counterclockwise moment comes from N, the normal force. And then for a normal force, I will say that this one, let's say here, N, tries to prevent the rotation. With some distance of x. And then we have the normal force N. Okay. So the clockwise moment by the F of F. So if I go here, this is what F of F tries to do. Okay. And this is what the normal force tries to do. That's arm times arm. Okay. This is what we have as a result. Plus N into X. If I do this one, so I will get that f of x, f of f 2.5 is N into X. N is 600, and then, sorry, N is 1200. F of f is 600, then X will be 600 times 2.5 by 1200. And that will be 1.25 feet. So what does it mean? It means that if it is a safe, if it is the G, and then from the G to here, okay, so 1.25 feet, it is enough for the N to prevent rotation. Okay, in this acceleration actually. And then there will be that at some point, if AGX goes up, so what we will have is that the arm of N will increase. And then that value of N, if it is greater than the edge of this part, if it is greater than this edge, what's that? 1.5 feet. If it is greater than 1.5 feet, so then it will tip. Because, and physically, I mean mathematically, the equation is right. You will have some value for the arm. But physically, this is the end of the body, end of the safe. It cannot, I mean, maintain its equilibrium because this is the end. You cannot have more than that. That's the reason that at that point it will tip over. Thank you.